The other day we worked with multiplying and dividing rational expressions or fractions. Today we're going to do some adding and subtracting and then some compound fractions. So when we are adding or subtracting, we need a common denominator. And you got to be careful because you may say that these two denominators are the same, but they're not. One is x minus 5 and the other is 5 minus x. So in order to make them both the same, we can multiply this one by -1 over -1. And then that gives us 2x over x minus 5 minus -5 over, and this becomes -5 plus x. And then I'm going to rearrange that so it looks exactly like the first one. So then we have 2x over x minus 5 minus -5 over x minus 5. Well, minus the negative means adding, so 2x plus 5 over x minus 5 is our simplified radical expression. All right, number 2. Right now it doesn't look very nice, so we're going to factor both denominators. So the first denominator becomes x plus 2 times x minus 1 minus 2 over, this becomes x minus 3 times x plus 2. So if we look at both of these denominators, they have an x plus 2 already. But for them to be exactly the same, we're going to have to multiply this first fraction by x minus 3 over x minus 3. And then we're going to multiply the second fraction by x minus 1 over x minus 1. And now we're not going to multiply out that denominator. We're going to leave it all in factored form. But the numerators we are going to distribute. So the first fraction, distribute the x minus 3 into the x. That becomes x squared minus 3x. And then the second fraction becomes 2x minus 2. Now remember there's this minus sign here, and then it's being distributed. So we're going to have to distribute that negative sign at some point. All over the common denominator, which in factored form is x minus 3 times x plus 2 times x minus 1. So now we're going to simplify the numerator. We have no other x squared, so it's going to be x squared. Then we have negative 3x minus 2x, which is negative 5x. And then we have nothing minus negative 2, which is going to be positive 2, over my factored form. Now, we would want to see if we can factor the numerator, x squared minus 5x plus 2. If we can factor that, then maybe we can cancel something from the numerator and denominator, but we're unable to do that. So this is our simplified answer. Here, we have 2 over x plus 1 plus 2 over x minus 1 plus 1 over x minus 1 times x plus 1, because we factored that. So if we look at the denominators, the first one has an x plus 1, the second fraction is an x minus 1, and the last fraction has them both. So we don't need to do anything with that fraction. What we can do is multiply the first one by x minus 1 over x minus 1, and we can multiply the second one by x plus 1 over x plus 1. So again, we're going to distribute the numerator. So we're going to get 2x minus 2 plus 2x plus 2 plus 1, because again we distribute this, plus sign, distribute that, plus sign, 1. All over our common denominator of x minus 1 times x plus 1. So that numerator, we want to combine our like terms. We have 2x plus 2x, so that's 4x. And then we have negative 2 plus 1, which is 1, all over x minus 1 times x plus 1. And again, if we could factor the numerator to cancel something out, we would do that. But in this instance, we cannot do that.
All right, so next we're going to simplify what are called compound fractions. And a compound fraction is just a fraction that has other fractions in it. So if we look at example 1 here, we have this big fraction that has this in the numerator and this in the denominator, but each of those fractions also has an x over 4 in them. So there's different methods you could use to simplify them. I'm going to use what's called the LCD method, and what that is that it looks for the least common denominator between the big fractions. So I'm not looking at these little parts here. I'm saying, what do I got to multiply the blue and green part by? So I look at all the little fractions here and I say, well, the denominator here is a 4, the denominator here is a 4. So if I multiply by 4 over 4, that will eliminate all these smaller fractions. So everything gets multiplied by 4, and the more you do this, you can start to take some shortcuts that you'll see in a minute. So we have in the big fraction, 1 times 4 is 4, plus 4x over 4. That's the top fraction. And then the bottom fraction will be 4 minus 4x over 4. Well, if you look at these now, you can simplify this by canceling the 4's. And then you're left with 4 plus x over 4 minus x. And you don't do any more simplifying from that. That's your final answer. All right, now here we have two fractions in the numerator, one with a y denominator and one with a 2y, and we have one fraction in the denominator that just has a denominator of y. So we can't just multiply everything by y. Because there's a 2 here, we got to multiply everything by 2y. And you can't say, well, can we just multiply the bottom by y and the numerator by 2y? Nope, you have to multiply the top and bottom by the same thing, because that's just a form of 1. So then we distribute to everything. That's going to give us 10y over y minus 12y over 2y. 2y over 10y over y again, and then minus 8y. And then we reduce all of our fractions here. 10y over y reduces to 10. 12y over 2y is going to be 6. And then 8y over y will be 10 minus 8y. Okay, so we're not quite done yet. 10 minus 6 is 4, so we have 4 over 10 minus 8y. But now I can divide out a 2 from all of this. So when I divide out a 2 from all of that, or reduce by 2, it becomes 2 over 5 minus 4y. And that would be as simple as we could make this. So on the next page here, we have 1 over x minus 1 over y over 1 over x plus 1 over y. And again, we have to multiply the same thing to the top and bottom. So if we look at those two fractions, what we can multiply by is xy over xy. So let's go ahead and do that. So xy over xy. And you might start to see this pattern that, okay, when I distribute this, when I distribute this to the first one, well, the x's are going to cancel, and you're going to be left with just y. And when you distribute to the next one, the y's are going to cancel, and you're going to be left with just x. If you want to do that to use as a shortcut, you can. For this video, I'll just keep doing it. I'll keep writing it out. And notice that, probably should have talked about it up here. These things that I'm multiplying the top and bottom of the big fraction by only get multiplied by the numerators. Okay. So when I go here, it's going to be xy over x minus xy over y over xy over x plus xy over y. All right, and then, like I was saying earlier, the x's will cancel, so we're left with y minus, then the y's will cancel, x over, x's cancel, y plus x. So then that would be our most simplified expression. We couldn't go any further than that. Now this last one, just because there's radicals, that's okay. And you'll notice there's radicals in the denominator, so you could rationalize everything, but the easiest way to approach this problem is multiply, again, by the least common denominator of all these little fractions here, and distribute. So it's going to become the square root of 2 minus 1 times the square root of 2 is going to be the square root of 2 over the square root of 2 over 4 square root of 2 times the square root of 2. So we can simplify this a bit. The square root of 2 is just going to be the square root of 2. Square root of 2 over square root of 2 is going to be 1. And then here we have 4 times the square root of 2 over 2. Those will cancel, and then we're left with just 4. So using this LCD simplification can make the problems simplify quicker, but there are other ways instead. Like you could have added the bottom, and subtracted the top. So you could have done 1 over x minus 1 over y, get common denominators and simplify, and do the same thing in the denominator, get 1 over x plus 1 over y, get common denominators and add them. But in this particular problem, this method worked more efficiently. So thanks for watching. Make sure to like and subscribe.